Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 29. And in this episode, we're going to be talking about something called snapshot testing. Now, we've actually had a couple of episodes on testing. We had Ian Cooper talking about TDD. We've had Stephen Poltz talking about mutation testing, which was a super interesting concept. And various other episodes, the topic of testing has come up in one form or another. For example, more recently with Kendra Havens, we were talking about Visual Studio, and she spoke about fuzz testing with PEX and MS and Teletest. But today, we are going to be talking about another type of testing called snapshot testing, which I haven't really used before, but I've been playing around a lot this week with it, and I must say it's making me very, very happy, and I can see this is going to save me an awful lot of time. So now is probably a good time to introduce our guest, who is the author of a snapshot testing library called Verify, to tell us all about it, Mr. Simon Cropp. Welcome to the show, Simon.
Hey, nice to be here, and thank you very much for having me.
Nice to have you on, and you're coming from sunny Australia, which is, probably a lot nicer than we've got at the moment. We're suddenly hitting winter, and you can feel the chill in the air.
Yeah, it's that nice time of year here where it's, not too cold at night and, mid to high 20s during the day. It's just, lovely time of year in spring.
Oh, very nice. Yeah, we're at different times of the day at the moment. So I'm talking to you at 10 a.m. in the morning, and I think, is it 9 p.m. over there?
Yep, 9 p.m. on a Friday night.
Friday night. So that's commitment for you, isn't it?
It's fun to do this kind of stuff and didn't have any plans. So yeah, it's good to do.
Awesome. So before we dive into snapshot testing, could you give our listeners a quick intro into your background and what it is you do?
So I've been a software dev for, I guess, just over 20 years now. These days, mostly working in large government departments. So yes, we're working for the enterprise and focusing primarily on .NET, although we're doing full stack style apps. So at the moment, we're doing Angular front ends and GraphQL APIs, and mostly my job focuses on working on back-end services to deliver the business functionality. So Verify is really my side project. We do use it at work, but it's definitely in the background, I guess.
I'm so impressed with all the different add-ons and things. I think we were talking on Twitter yesterday, and you said, do you reckon this could do with a mediator add-on as well? It's impressive how much time you can dedicate to this on top of a full-time job.
Yeah, so speaking to Scott Hanselman's approach, he talks about what the right size Lego is for various things. And I like tools that are very pluggable. You opt in for all the different features you want. So I design software and frameworks and libraries with that in mind so that I can pick and choose all the different little add-ins I want just to meet my scenario. So with that in mind, I've also gone through and made an approach with many, many small repositories that deliver those little bits of Lego in a way that's manageable and scalable and hopefully doesn't require too much effort on my time. So I have practices and patterns in place to manage all that stuff. So it usually takes me, 4 or 5 hours to spin up a new repo and a NuGet package. And I generally do that probably on average about once a week. So yeah, I'm at about, I must be almost about 180 packages under my name at the moment.
Very, very nice. I need to do more open source stuff. But I think in fairness, because I do this in the user groups and stuff, and a family, and a full-time job and company, I guess I need to say no to some things. But yeah, it'd be good to do a bit more open source stuff. So before we actually start talking about what snapshot testing actually is, I'm just going to do this episode's listener mention. And this one goes to Alf Lefdow, who very kindly bought me a coffee. Well, actually 3 coffees. I've recently added the Buy Me a Coffee widget to the podcast website, and Alf very kindly bought me these 3 coffees and said, "Thanks for the great podcast and great work with the user groups. Say hi if you come to Oslo." And to be honest, this actually really made my day. Not the money really, but more the thought behind it, the appreciation really meant a lot. So big, massive thank you to Alf. And I also want to say a big thank you to the awesome developer community on Twitter. So last week I tweeted out about the podcast, asking if people can help me spread the word. And I was gobsmacked by how many retweets this got. So I just want to say a massive thank you to everyone that retweeted that. That was mind-blowing, really, to be honest. Okay, so snapshot testing. For the listeners that don't know what it is, could you give us a quick overview of how this works?
Well, it occurred to me earlier when you were listing off the various people you had talking about testing earlier that snapshot testing is probably a misnamed. It would be more accurately called snapshot assertion. It focuses mostly on the assertion side of the data, but it does change how you work, and the sum of the parts is greater than the smaller concept. So snapshot testing is the idea that you take some data and you serialize it. That serialized data gets placed in a file, that file gets committed, and then the next time you run that test, you re-serialize the new data and you compare that to what's existing on disk. So in practice, mostly that is, let's say you have a complex object model. That's the result of calling some code under test. You take that model, you serialize it to, in this case, JSON. That's the approach I've taken. That JSON gets written to disk, and the next time you run through that, you get a new JSON file, and that file gets compared to the one on disk. That's the core concept of snapshot testing, which is what all different libraries use. Some don't do the JSON serialization part. They just expect text, and you handle all the other bits. But that's the core concept. There's a couple of extra levels that also happen with some libraries, and that is they take the comparison side of comparing those two files and deliver functionality around that to make it easier to compare those things. And that's where you get into the diff tool side of it. But diff tool is kind of a superset of snapshot testing. Not all the libraries do that.
Cool. So when you say it writes the result to disk, presumably that result then goes into your source control so that that's then the accepted test pass, if that's the right way of phrasing it?
Yeah, so different libraries call them different things. Some call them the master snapshot or the golden snapshot or the approved or the verified. There's different naming about how those things, how they're named on disk, but they're all effectively the same thing. It's just a serialized representation of the result of some code under test.
If I think about the amount of time I've spent writing code to generate expected data to compare in my asserts, this is just going to save me a ton of time moving forward. And also, like you mentioned about the diff tools, one problem I sometimes have in the past is I've written this expected data, I've done my asserts, so at some point the test fails. Actually visualizing what's changed in the JSON that's shown in my test output window that's not nicely formatted or anything, that can be a pain in itself. But when I've been playing this week with your Verify library, and it's opening my diff tool of choice, which happens to be WinMerge, but I can see the JSON before and after. It's so easy to see what's changed. And then I can just literally copy the block that's changed from left to right in the diff tool, save it, and that's accepted the new source of truth. And that's it. It just works.
Yeah, it's an interesting change to how assertions happen, because usually that loop would be something failed. The assertion library tells you, the count is wrong, but you have no concept of the peripheral data around that, what the full context is, and you very often end up going, well, I'm going to have to debug into this thing to work out what the outcome actually was. So when you take the snapshot testing approach, because it's so much easier to accept changes and manage the impact of changed data, you end up often over capturing data. And that's generally in an assertion style approach, that would be a negative thing. But with snapshot testing, it's not, because it's so easy to adapt the result to change. So that when you actually have a failure, you end up having this extra data surrounding that information that also informs why the test failed. So it's kind of like when you're doing a diff, and if you're looking at a diff on, say, GitHub or a diff tool, just seeing the files that changed is the equivalent of your assert. But actually, most diff tools show you the 4 lines above and the 4 lines below, right? And that informs you being able to understand what actually changed. So it has that similar approach.
Does this mean that there's no way of doing a kind of TDD style of testing with this, because you've always got to write your production code first to generate the snapshot?
Not really. You can do exactly the same thing that you do with test-driven development. You can create the expected output that you want. One out there example I've seen was Verify supports not just serializing object models, it can serialize anything that you can write to disk and still reason about. So in this case, it was serializing a WPF form onto disk in the form of a PNG. Okay, so the first PNG that you have, you actually just draw with a crayon. Like the designer gives you what it should look like, and you whack that on disk. It can be anything. It can be a diagram from, a mock-up tool, anything that gets you something on disk that you can target to make it look like. Now, it doesn't have to have all the finesse, doesn't have to have all the coloring, etc., but it's something on disk that you can work towards. So in some cases, that would be your designer gives you an image of what they think the screen should look like, and you put that on disk. You start coding away, and as you build things out, you run the test. Oh, look, the top button's there, but we're not quite happy with that yet. And eventually, each time you run the tests, the comparison gradually begins to look more and more like the outcome, what you expect it to be. And at the point where you're happy with it, it looks enough like it. You rarely get pixel perfect. At that point, you can say, show it to the designer and say, is this okay? And they can say yes, you accept it. So that's your test-driven approach for a form style approach. It actually even works better when you have something that has a text representation. So if you're designing a new control, you can get your HTML expert, your CS experts to say, how should this look in HTML and CSS? They can give you all of that HTML and CSS, and you're doing data queries and whatever else to generate that CSS. So they give you the files of how it should look. You place them on disk as the verified files, and then you start coding. And that's exactly the same way that test-driven development works, but it's on steroids because you can assert against anything that can be serialized to disk.
This sounds incredible. My playing around this week, I've just been using the normal set like JSON kind of. I've got a set of objects, and your tool converts to JSON. That's what shows in my diff. But yeah, like what you're describing now just kind of opens up so many different use cases for this.
Yeah, so we've been through similar approaches where you might have your SQL expert, and they're like, there's something wrong with this query that you're putting through Entity Framework. It's causing too much load. Now, they don't necessarily know Entity Framework, and frankly, I don't know SQL very well. But with Verify, you can take an instance of an Entity Framework query. So that doesn't even need a database to talk to. And you can say serialize SQL that would generate to disk. And you have that copy on disk, and you get your SQL expert and you say, so here's what we currently generate based on this query. What do you think of that? They can then tweak that, saying, oh, we want it to look more like this and have this kind of characteristics. You make those changes to the file. Then you can go and reverse engineer how Entity Framework's translating your link statements to change it to closely match what's on disk. So again, test-driven development, but this time the target of what you've defined and working towards has been defined by your SQL expert.
So is that turning on Entity Framework's SQL logging and like hooking into that somehow?
No, the API that Entity Framework uses to translate a iQueryable that's in memory to a SQL statement is a public API. So in Verify, there's an extension point that says, for this instance of this type, here's how I want you to serialize that when it's passed in. So if you just pass in an instance of an iQueryable, so you just write your link statement, you don't need any running database or anything, it's all in memory. You pass that to Verify, it will serialize that to disk as to how it looks in SQL.
Wow. When I said this is going to save me so much time, I've changed my mind because now I'm thinking back to all my projects that I've got to go back and rewrite to use this.
Well, there's another interesting side effect that you have where an assertion isn't a very good way to communicate to people, where you look at an assertion and you kind of need to reason about. It's kind of like having plain text of how to do a string manipulation versus having a regex. One you can reason about and one you can't without sitting down and spending some time trying to understand it. So with snapshot testing, as a side effect, you have screens checked in, you have SQL queries checked in. It also supports snapshotting a SQL Server database schema. So as you change your Entity Framework or whatever other tools you're using to generate your database, you rerun your test and it rewrites that schema to disk. Or if you're doing a forms, it's rewriting those PNGs to disk. Now you have an evolution of how the app changed over time. So you can do diffs between two versions of how the exact SQL looked between two different deployments and say, oh, we had a performance degradation between these two deployments. Let's go do a diff between the two SQL schemas in source control and see what could possibly have changed. It also means that when you're trying to get approvals to get something deployed, like sometimes you need to get approval from the SQL team. You can give them, we're going to deploy it. Here's the diff between the old SQL schema and the new SQL schema after you run the deployment. It also means that you have a mechanism of communicating with DBAs or designers over time. You can get them to come down and say, we've made all these changes to the UI. Here's the before and after of all the different screens that we've got snapshots for. And they can see how those changes look and make decisions about them without having to log into a real system, contrive the data to get to that scenario, have the right permissions and all that kind of stuff. You have all that stuff on disk.
I guess, as you say, it's kind of opening up lines of communication, which maybe with normal testing, naturally a developer, because it's very code-based, a developer would just go and write their own expected data and code, and that's it. But because these are actually tangible things that are understandable by non-developers, like images, like you mentioned about the mock-ups, and you'd start with that, and you can show your designers, and then your DBAs.
Yeah, there's actually one negative there you kind of touched on, which is if you're crafting what the snapshot is, what you're targeting in text inside the test, it means you can see the test co-located with the actual expected outcome. And that's kind of nice. The problem is it's buried in the code. So you have this kind of positive and negative of that assertion style of testing. So snapshot testing, all the libraries I know of actually write it out to disk in a different file. So you have this kind of two things you need to reason about when you're actually doing the test. There's a couple of things Verify does to mitigate that. One is it's got some MS build smarts in there so that it knows how to nest verified files underneath the test class. So I'm not sure if you noticed that when you're looking at it in Visual Studio or Rider, if you expand a test, all the verified files are actually nested under the test class.
I did, yes. Although it seems to sometimes do that and sometimes not. So I'm not sure whether I couldn't work out when it wasn't doing it.
Okay, well, raise a bug for that one because it definitely should work. It's a convention-based thing that directs MS Build to nest them under there. So it's kind of a trade-off, and I don't really know how to fully mitigate that. But I think the current status of having things on disk has significantly more value. But it is one of the pushbacks you get from people when they're initially considering using snapshot testing.
Yeah, I guess if you want it in line in your tests, then that's probably a kind of test where you've got like a very simple assert rather than generating more complicated expected data.
Yeah.
And I guess that leads to the next question. Are there scenarios where you wouldn't want to use snapshot testing and just use normal asserts?
Yeah, there is a few. Range-based stuff. So we want the performance of this thing to be under 10 seconds. Because the outcome is, what you're asserting against is a number that is changing, you can't snapshot test that, right? Because it will change each time it's written to disk. So one thing that should be pointed out there is snapshot testing is not a replacement for traditional asserts. They work side by side. You can have some assertion test and some snapshot tests within the same test method. It's not considered a replacement. There are some other ones in there. There's certain date combinations where you really want to assert that nuances of different date math and how that works. So often in those cases, you have some asserts that is handling those edge cases, and then you also snapshot test some data as well, just so you have that state as well.
Yeah, so I quite often use fluent validations, and I quite often use for date times the extension method is in between. It's not called that; it's something similar where you can do or is close to. There's various extension methods which is quite useful, which I guess wouldn't fit with snapshot testing.
Use fluent validation to verify inside your tests.
Sorry, fluent assertions.
Oh, okay, yep.
There's too many libraries beginning with fluent.
Yeah.
But so how does it work with if you've got some JSON or something that you want to snapshot, and then maybe you've got timestamps or GUIDs or things within that JSON which are going to differ each time?
Yeah, so there's a concept called scrubbers, and a scrubber is something that plugs into the pipeline of Verify so that after you pass in the data, there's two levels. One happens during serialization, so you can scrub things based on the JSON.NET APIs, so in a strong type manner. And then there's, after it's serialized to text, you can also have text-based scrubbers that do regex style replaces or line replacements and all that kind of stuff. So there's a few default scrubbers that are already plugged in. So if you pass in, say, a model that has 3 different GUIDs in it, it automatically detects those, and the first one will be named GUID 1, the second one GUID 2, and the third one GUID 3. If one GUID appears twice inside there, you might have GUID 1, GUID 2, and then GUID 1 again. And the same thing happens with date times, date time offsets. There's a few other things in there as well. So by default, those things are considered fragile and causing tests to break, so it automatically scrubs those. You can turn that off, but usually it's satisfactory. So often you'll have, we passed in this information with a query that had this GUID in it, and we got some results back that had that GUID in 4 or 5 different locations because the IDs correlate. So in the result, you can actually see that GUID tokenized to something that's more human readable.
Yeah, when I was playing around with it this week in my blob of JSON, I saw datetime_1, I think it was. And I remember going back and thinking, is this a bug in my code? Have I doing toString on an object rather than, but then I realized quite quickly, so it didn't cost much time, but it was really interesting because I realized, I realized what it was doing. And it's really nice actually, because to do that manually would be quite a pain.
Yeah, it's fiddly to do that on your own. There's also some regex smarts in there where, let's say you're generating a report of HTML, you can actually have, this is an opt-in approach because it's a bit more time consuming, but it will run a regex over whatever text blob you have and attempt to do the token replacement of inline GUIDs and inline dates as well. So that means, you have links in your resulting HTML. Those links don't need to be fragile. Right, they'll get token replaced inside that text blob in the same way that the JSON serialized version would.
Nice. In the code I was doing this week, I did add a scrubber to replace, in the JSON, replace one of my fields, which was actually automatically incremented by the database. It was in the database identity primary key column. So I didn't want that to be compared. So I added a scrubber, but I used the scrubber, I think it's add scrubber with replace or something, and it took a lambda. And then within that lambda, I did regex.match. So I was kind of like manually doing regular expressions. Was there a method I could do regex without having to do it that way?
I think I'd have to look that up. I'm not, it's one of an edge case. I'm pretty sure that there's two scrubbers, one that does a regex replace, and you pass it in a string that's a regex, and another one that does a regex remove.
Oh, nice.
So yeah, so that'd probably help you with that. Most of the string-based scrubbers also work at a line-by-line level, because that's generally what you'll need to replace. Rarely do you need to do token replacement for data that's spanning multiple lines.
I see. I quite like the fluent syntax of it as well.
Did you look at how that's implemented?
I didn't.
So I've effectively, that Fluent API, it's a class called settings task, which is not something you actually use as a first class API in the library. But when you do a verify, it returns that. If you await that, it's got a cast to task, so it knows how to await it. But if you don't await it, you can append extra settings to it using the Fluent API that pokes in there. So it's kind of this weird side effect that you can write a really good Fluent API only because it's an awaitable thing, right? So it's only the last point of a Fluent that it actually returns back and does the awaitable.
Nice. That is really cool. I've just opened up in Rider now, so I'm gonna try that. So just for the listener's benefit, in my assert, the syntax is await verifier dot verify, which seems to be static, and I'm passing in whatever I want to verify, and that's it. But then I can, after that, do dot and then some extension method. I presume they're extension methods. And as was mentioned before, I've got like scrub lines with replace, and then you can do that. But then you can chain these together, which looks really clean and powerful. But I'm just going to try what you were saying and F12 into it using Rider's deserialized. I know it's open source, so I could go to the source code, but
yeah, it's already on disk. Does Rider actually use a decompiler, or does it look up the source symbols?
I think it uses a decompiler.
Okay.
I'm not sure. It would be good if it could look up the source thing using, what's it called, the source link, isn't it?
Yeah, it is source link. But it basically correlates those PDB symbols back to GitHub.
Well, maybe it is.
Usually you can tell if there's inline comments or something.
Yeah, there is actually. There's the XML comments. So maybe this is, if I look at the, I'm just looking at the path of the file, and it's Rider, Sharper host, source cache. Yeah, it's hard to tell whether it is source link or not. But yeah, it doesn't look like decompiled, more messy code. It looks fine.
Yeah, some of the decompilers do look it up online. It's hard to tell what it does under the covers. So that API you were talking about, so for the majority of features that Verify has, there's three approaches to configure them. So there's the static approach, which affects all tests. Then you can have an instance-based approach to the settings. So you can spin up a instance of settings, apply any of the custom settings, which will inherit from the static one, and then that settings can be reused across multiple different tests. So you can share that in any scope that you want. And then there's the Fluent API, which is generally to just tweak small things on an individual test basis. So it kind of has, well, I think, the best of several worlds there. So you pick and choose where you want those settings to apply.
That makes sense. So I guess kind of like the global ones, say you wanted to change the directory that the files get written to. I don't know if there's a setting for that, but then the scrubbers might be per test basis. You've got like these different scopes.
Yep.
That's really nice. So we've mentioned that this launches diff tools and things. Now I'm assuming that when you're running it in on a build agent, CI/CD and stuff, there's ways to turn that off.
You don't need to. Out of the box, the feature you're talking about is called Diff Engine. The launching of a diff tool was actually a feature that I figured multiple different snapshot testing libraries would like to use. So I wrote it in a way that it could be consumed by multiple different libraries. Currently, that diff engine is being consumed by approval tests, Shouldly, and Verify. But in terms of your question, when it's running on a build server, it has built into the diff engine, it looks for environment variables and various other quirks of how things work, so that it won't pop up diff tools if you're running on Appvea, Travis, Jenkins, GitHub Actions. There's like a dozen that automatically detects. There's also a code API that you can explicitly write your own logic on how am I on the build server, and then people can't see my air quotes, and then you can decide to disable it.
I'm glad you explained why I was laughing then.
You don't even realize when you're talking to someone in person.
Yeah, that's really cool. And I'm assuming that if when like locally development, if a test fails, I get a nice diff, that you still get nicely rendered console output showing what's changed. But then I guess you can't do that with images. So how does that work? So
there's a few things. So if it's text, the exception that's thrown has the path to the before and after file, and it has the full before and after text. For really big blobs of text, there's ways of tweaking that down so you only have smaller bits of text in your exception. For binary assets, there's some documentation on how to leverage the features of the various different CI servers that says when it fails, by convention, copy all of the star.received files to the build output, like the assets of the test run. So then you can actually download those assets. So generally what you do is you actually, the assets will be a, blah blah .received.png. What you generally do is you download that, you rename it to verified, and you dump that over the top of the existing one on your local disk, and you look in a diff tool and go, that's what went wrong. Yeah, so it's not possible for Diff Engine to do that out of the box because those features are YAML files inside GitHub Actions or
Yeah, I guess from the local thing, that the workflow you just described about copying that file over the top of the other file, I've noticed this week that kind of happens automatically because of the diff tool launching, where even if it's the first run, so you don't have a snapshot at the moment, then it's launching up WinDiff, which is my chosen tool, but whatever it is. And on the left, I've got what's happened, like what the actual production code has generated. On the right, I've got an empty file. And then I can just, on the diff tool, say copy left to right, save, and that's accepted it. So I've not manually had to copy that file across.
Yeah. So most of the diff tools have a button and or a shortcut, keyboard shortcut, that you probably want to look up for your diff tool. It basically says accept this change. It just streamlines your workflow a bit. In terms of the empty file, how do you think the empty file is created for, say, a Word document or a PDF?
That's a good point.
Yeah, there's a little hack in there. There's a different project that I consume called Empty Files, which just has a whole bunch of 1 kilobyte or 2 kilobyte binary files for all different document formats. And that's required because a lot of the diff tools that you launch will error if you say compare a new file with a non-existent file. Like they just flat out won't allow it. So then I went, okay, I'll just create a 0 byte file. And then it's like, nope, still error. One's not a Word document. Like it just fades to error out. So for like, I don't know, there's probably 50 different file formats that it works out of the box. So that when you create that empty verified file to do the diff, you get this tiny little file on disk. It's kind of a bit hacky. I would like most of the diff tools to support, a non-existent file because it's the first time. But like this isn't really their core business model.
I just love the way that you're doing this in your spare time. It's not your full-time job, but all these little pain points you're dealing with.
Well, I do use it heavily at work, but yeah, this has come over years of playing with different libraries and trying to work out how to do this. And each time I hit some friction, or anyone hits some friction, I really think about it a lot and try and work out a way of, what's the best thing we can do in that scenario. And yeah, the diff engine launching is, without that, snapshot testing is very difficult to make an argument for. It just takes it to that next level.
Thinking back to at the start where I was saying about past episodes, we've in one way or another talked about testing in some form in a lot of episodes. I'm thinking about, there was an episode where I was joined by Jason Bock talking about C#9 source generators, and we spoke a bit about testing in that. And thinking about it, that sounds like a really good use case for snapshot testing, where the snapshot is the outputted source code that your source generator is generating.
There's an extension for Verify that does that.
Oh, really?
Yeah.
You've got extensions for everything.
Yeah, so you pass in I can't remember what the instance called, but it's effectively a code DOM. The output of it is some kind of instance that you pass back to Roslyn. If you pass that instance over to Verify when you're using this add-in, it serializes out the C# code for you and snapshot tests it.
I just want to say for the listeners that was not a knowing question. As in, when I mentioned about the source generators, I did not know that there was actually an extension. I'm going to go to the site and have a look at all these extensions because there must be hundreds.
There's another cool feature that we do, which is the scenario where you're snapshot testing. Usually this happens when you're snapshot testing the output of a browser. So you're using Puppeteer or Playwright as part of a test. You're spinning up a browser and you're taking a snapshot of that browser. So the output of that is HTML and a PNG. Then you write that to disk, and that's great. You check that in. But then someone else runs it on a slightly different machine. And how browsers work when you do a snapshot, it's just not consistent. Very minor changes to systems can cause very minor changes to the outcome of a snapshot. Not necessarily perceptible to a person, but binary on disk, that file is different. Therefore, it would fail the test. So there's a feature in Verify that does lossy comparisons. So you can basically plug in, I think there's about 4 or 5 different algorithms for image comparisons, and then you set some thresholds on the dials and the type of comparison you want and tweak the algorithm a bit. So that it means you can say that, look, if it's just changed 1 or 2 pixels in that file, we don't really care. So you set these thresholds, you dial them up and down based on how fragile it is, but it means that you can greatly reduce the false failing of tests. Right? It doesn't nag you about this has changed when the outcome's still valid. I know we had a chat about Diff Engine Tray, and you're still not using it?
No, well, bear in mind that I'm kind of I've only just started using it this week, and it's in amongst actually having to actually do the production code too. So I've not had a huge amount of time to play, but I did install it, and I found that because I've only got like a couple of asserts at the moment using Verify, and like that Verify is actually testing a lot of stuff because it's an integration test. But I found that because when the test failed, it launched WinDiff. I'm used to WinDiff quite heavily. I know all the keyboard shortcuts. I could just copy it to the right, accept, and close it, and that was done. So I found I didn't really need the system tray tool.
Well, we'll step back, and I'll explain what it is, and then I'll speak to your point to, again, try and convince you that it's cool. So Diff Engine Tray is something that sits in the tray of Windows. Currently, it's only Windows specific. I'm working on a Mac version, and it tracks all the failing snapshots on your system across all different solutions. It then groups them in a UI that you can optionally look into, and then you can pick and choose based on grouping or individually whether you want to accept or decline any changes. It can also manually open the diff tools for those failing changes without needing to rerun the test. So it's quite useful when if you're snapshot testing a website and you have a change where I decide to change the font. You might have hundreds of tests fail. So you don't necessarily want to open all those hundreds of tests in your diff tool and accept them all manually. So Diff Engine Tray has a feature where you can just accept all those changes or group them or review them in whatever way you want. In terms of your use case where you're used to using a specific diff tool, I found that only works as long as you're dealing with a subset of file types that diff tool likes. So eventually you might get into snapshot testing binary files that diff tool doesn't like, and then you end up popping up multiple different diff tools for different scenarios. You might find it a bit easy to have a consistent keyboard shortcut approach that manages all the different diff tools.
So does this tool have a global hotkey so you don't have to reach for the mouse and select it in the system tray?
Yeah, so it has 3 hotkey bindings that it does. It has a discard all, it has a accept all, and then it has an accept all that are currently visible. So when you're doing snapshot testing, a visible snapshot is one where you currently have a diff tool open for that snapshot. So you might be, if you're in a bad state, you've got lots of failing tests due to a change, you might be manually cherry picking a few of them and making them pass one by one. So many could be in a failed state, but you might have 5 up in diff tools. All of those look good. Then you can do a shortcut that just accepts those currently that are visible.
I expect that the more I use this and the more tests I have, the more I'm going to want to use this system tray tool. I think because, as I say, I'm starting off with like pretty much just one assert that's covering an integration test while I'm playing around with it. It's literally just one thing, and I know that's JSON based, but I'm sure based on your description that I'll be reaching for that system tray tool quite soon.
Well, let me know how you go. Yeah, there is a Mac version in the works for that. It's just, I'm a Windows person, and it was just easy. And I wrote it in WinForms ages ago. And of course, I picked the technology that, can't be run anywhere else. So, but it is nice when you're running, because I run that all the time on my dev machine. It's nice to have, it's written in WinForms, so it's 18 mega RAM. It just works. There's no big resource hog. So did you look for the other add-ins and see if there's anything else you want to use?
I've opened it up, so I think for the listeners' benefit, I won't read out them all, but so I've got things like, you've mentioned verify.source generators, there's Microsoft logging, WinForms, RavenDB, NodeTime, Diffplex. In fact, yes, I'm going to read them all out actually. HTTP, XAML, Xamarin, SQL Server, Fash. I don't know what Fash is actually. Quibble, Aspos, Cosmos, NService Bus, IC Sharp Code Decompiler. Is that what you mentioned before?
So that was written so that when I'm messing around with decompiling code or doing IO manipulation, I can actually snapshot test the binary data of an assembly. So I can say, pass it in an assembly and it will give me back the C#. So I have some idea of what it actually looks like. That's a very niche one. I don't think anyone will be using that.
Image Sharp, Angle Sharp, Grape City, Sync Fusion. Oh, I'm using Sync Fusion for a client, so that should be quite useful. And .NET, headless browsers, Blazor, ImageMagick, ASP.NET Core, Entity Framework. I've got a next, but how do you do all this? I've got a next button, so it's paginated even. Verified.public APIs, Pandoc, ORM Lite, and Martin as well.
Martin? No, I think the last 2 you've read is just I'm misspiking. I don't think they're officially done yet. You're looking for the repositories, right?
Yes, I am.
Yeah. If you look on the README of Verify, the list of currently supported ones is probably about 3 less than what you just listed.
Right, okay. Yeah, it's interesting that there's a project with Martin, though.
Yeah, it's for Postgres, document database over Postgres.
Event store.net. An event store on Postgres. Yeah, okay, so maybe I misunderstood what it was then. It says .NET Transactional Document DB and Event Store on Postgres.
Yeah, so think RavenDB, but the backing store is Postgres JSON. Because Postgres has very good support for JSON documents, and Martin is kind of leveraging on that functionality into the .NET space. My plan was there to do the same kind of support for Martin that Verify has for Entity Framework. Right, so snapshot testing of a schema or the queries or various other things so that you can actually get better visibility of what's happening under the covers. So back a step, you mentioned Microsoft logging. I guess it's a pattern that I've been using, which I call recording for lack of a better term. But in this context, it's any library, framework, or API that lets you plug in and listen to events. You can record those events and place them into a snapshot. So it's a bit different from what you've done so far. So you're just passing in a model into Verify. So if you wanted to say, let's say you've got something that's talking to a web API, you do your arrange. After you arrange in your test, you do start recording HTTP calls. Then you do your act, and then you do your verify. You only need about one call that says start recording HTTP. Now, under the covers, when verify looks at the thing you've passed in, it'll serialize that and treat that as normal. But it'll also check a lookup of, have we recorded anything else during this process? It will also append all those recorded statements to the snapshot. Now, you could be recording log statements with Microsoft logging. You could be recording SQL queries done to SQL Server. You could be recording web API calls that are done through HTTP. You could be recording Cosmos DB API interactions. It's kind of nice to be able to do this, especially if you're testing legacy APIs, because you can suddenly get a visibility of what's happening under the covers without changing any of the production code. Right? You can just say, record HTTP calls during this test, and you don't need to change that stuff. You don't need to capture it. You don't need to change the code to pass it back. It just happens. So you can do recording with any API or library that supports plugging into those changes. Oh, another one's in Service Bus. You can do recording of stuff in Service Bus.
Wow. So I guess in a microservice kind of architecture where you've got APIs calling downstream services, that just sounds perfect.
Yeah, so you were talking about Mediator. So let's say your calls to Mediator are dispersed through the code base. So you're testing something, whether it's an integration test or it's a unit test, it's kind of irrelevant. But you want to be able to record all of the interactions that Mediator does. So the messages it sends, the messages it receives as part of doing this test, and then you want to be able to capture that stuff. Now, ideally, you want to be able to do that without having to return all that information from the code under test, because that would be very difficult to surface that information. So that was why I was saying, does Verify need a plugin for Mediator so that we can capture that information and support as a first-class citizen?
Yeah, I guess it depends how different people use Mediator. From the way I use Mediator, I don't really use it down the call stack like you're describing. I would tend to have it would be the entry point to the app. So, for example, a web API controller would do mediator.send. An event handler, which is responding to message on the queue, would do mediator.send. And then the mediator handlers don't know or care whether it was executed by an API request or whether an event on a queue. But I don't tend to then use that further down the call stack, if that makes sense. But people use tools in different ways. So it might be, if any of our listeners use Mediator in the way that this would really be useful, then I think that's probably worth shouting out.
It's actually interesting, the recording approach. Every place and code base that I've looked at where I've said, I've got this little feature I want to turn on just for doing a few of these tests. We're just going to record, like, how many SQL statements do you think are executed as part of this code that you're testing? You know, people throw out numbers, 2, 3, 4. And how much SQL do you think is executing? Oh, a few lines. Okay, let's just record all the SQL statements that are being done as snapshot into the test. And you get this wall of SQL. And they're like, oh, yeah, that's not good.
I'm laughing because I can probably relate to it so much. I'm really interested to take some of my code now and do exactly that, because, well, I'm quite scared to do that, actually, to be honest.
Well, Entity Framework does a really good job of plastering over that. I mean, I guess it's, most ORMs do that, but there's just so much to know in the scope of ORMs to have even the lowest level of understanding of how a link statement will translate to SQL. And usually you're operating at a level above that. You just don't, it doesn't occur to you to go and work out what it's actually producing on the SQL Server. And when people do, it's a responsive thing. They're doing it, oh, this query's slow. Let's turn on SQL statement tracking, or I forget what it's called. Let's run this thing in an environment, have a look at the actual SQL statements. Oh, we'll go and fix that one. Well, that's great. You fixed one now, but you haven't fixed it in a way that means it's not going to regress. You haven't fixed any others that might have a similar problem. And you've had to do it in a way that took a lot of time and was frankly cumbersome. So if you do that stuff as part of your testing regime and you have that snapshot tested, it becomes second nature to glance at that stuff when you're actually doing development. You can fix it earlier or decide not to fix it, and it's a conscious decision.
I guess that's also not just checking what your code changes have done to the Entity Framework query. Say, for example, you upgrade to a newer version of Entity Framework and Microsoft have done performance optimizations, or maybe they've regressed somehow, then straight away being able to see that and say, oh, that's interesting, that is much better, I accept that. Or, oh, hang on, that's much worse. Microsoft, why have you done this? Raise a support ticket. Just getting that visibility straight away.
I actually had that just this week because we updated to Entity Framework 6 and I had reran all the tests and I had 100 or so tests fail. All the SQL that it was executing had changed in small ways. Nothing was bad. There was no bugs there. And they had done, obviously optimizations to tweak performance. So, I bulk approved them, but I'm glad that threw that up in front of me, because if they had done some changes that caused a blowout of SQL statements or stuff that's not optimized, you get to see it. And otherwise you just never would. Most people wouldn't even, there's no way you can go through and manually verify all the SQL that is being created by a non-trivial app. It's just not possible for a human to do.
And you may have said this already when you were talking about the scrubbing, but do the scrubbers automatically deal with trivial white space changes?
No, they don't. And that's because it's very hard to tell what is trivial.
That's true. It's different depending on what it is, I guess.
Yeah. So there is some prettifiers that you can apply. So your code might be generating HTML and it's generating minified HTML. There's a plugin for Angle Sharp that will prettify that HTML and make it all nicely indented so that the snapshot is actually human readable. So that's opt-in. And you can do the same with there's SQL statement scrubbers that clean up SQL and XML scrubbers and JSON. So you can clean up any format that you want, but that's always opt-in because you can't tell if you passed in some HTML that you're expecting to be minified because that's the design of the system, you would be surprised if a snapshot showed you different HTML from what you passed in. So yeah, all that stuff's opt-in.
Going back to what you were saying before about generating snapshots for UIs and that kind of thing. So for example, say you had an ASP.NET web app or Angular or React or anything, and you might use tools like Selenium or Playwright or that kind of thing. How does your snapshot testing actually get that screenshot in the first place to do the comparison?
Yeah, so it doesn't have any opinionated approach as to how you use Selenium, Playwright, or Puppeteer, but it does have converters for the various different objects that those things produce. So I can't even remember the proper term, but it might be an iDocument or something from Playwright, which contains your HTML. So if you pass in the instance of your iDocument, Verify knows, oh, that's a Playwright document. I know how to use the Playwright API to get the HTML out of that, and also give me the screenshot as well. So it effectively says HTML to disk, and it also talks to the running browser instance and says, give me the rendered image for that, and writes both of those to disk. So you have the best of both worlds there. You have a text representation of what the HTML looks like, which is something that's very easy to reason about from finesse of small HTML changes, but you also have the blunt image, which is how it actually looks. And it can also, the other thing is, when you're doing that kind of stuff, it's important to remember that you can do it at the page level or you can do it at the control level. So you can pass a control instance into Verify and it will just do that subset of the HTML. So that helps you really narrow down what you actually want a snapshot. You don't want the thousands of lines of HTML when you just care about the rendering of this specific control for this test case. So it'll take the HTML just for that control and just the screenshot for that control and snapshot test those.
So can that hook into like Blazor components and just test a single Blazor components HTML.
Yep, so there's a couple of things with Blazor components. So when you're running Blazor components inside a .NET test, you're actually running the Blazor code model, but you're not running it in the browser, right? You're running it inside .NET 6 or .NET 5. So in that case, you can capture, generally there's two things you capture. It's the model, if any, that you're binding to, and it's also the HTML that results from the current state. If you want the actual image, you need a browser to actually render that. In that case, you can manipulate your Blazor app in the same way that you would manipulate any other HTML app and screen capture those through the headless browser extensions. So Verify has support for snapshot testing raw Blazor components. If you just pass it in, you'll get the HTML and the model. But it also has support for the B-unit testing framework. So for any of your B-unit tests that you have, you can just pass in because B-unit has I think it's called a test component, which is a thing that it uses to orchestrate how you manipulate the component. You can pass that component into Verify, and it knows how to, again, extract the model and the HTML from that B-unit context.
That's quite cool. B-unit, is that Eagle? Is it Hansen, is it?
Yeah, Eagle Hunts, yeah.
We've spoken before potentially about doing an upcoming episode on B-unit. And I know Chris Sainty, when we had the episode on Blazor, he raved about it. So that's going to be another episode on testing. There's a theme going on here, I think, with these episodes.
Yeah, the other thing with snapshot testing is it often decreases the need for manual testing, because you end up with, in your, say, your B-unit scenario, your browser automation scenario, you can pass in a model that's the current state. Then you can say, click this button and click that button and do this. And now capture me that state, and you get the HTML image for that state. So it means you now have confidence of that scenario moving forward. Has that scenario changed in any way that produces an invalid snapshot? So, manual testing is still required, but it means a lot of those scenarios that you would normally need to do manually can now be codified into a test. And one of the complaints that a lot of people have about testing UIs is, it's just too hard, it's too fragile. Automating those things through, they break from small changes. Like, I put a lot of effort into supporting UIs as a first-class citizen in snapshot testing, with scrubbers and sensible manipulations and lossy comparisons, and it's designed to mitigate as much of that fragility of UI testing that is possible.
A lot of people I've spoken to this week or past weeks and asked, have you heard of snapshot testing? A lot of developers. I've just got blank looks and people shaking their heads. And this, just all the things you've spoken about today and my experience playing around with it this week, it feels like this is incredible, and it should be a much more widely known concept that developers jump to using and have in their toolbox. And yeah, it really surprises me that it's so powerful that it's not a more widely used concept.
Yeah, it is strange how uncommon I see it used. For every team that I've joined, because I'm a contractor, I move between projects, I'm yet to move on to one team where they're like, oh yeah, we use snapshot testing. Not just Verify, just any snapshot testing. A few people have used, is it Jest do JavaScript snapshot testing? I think it has a snapshot testing component on the JavaScript side. A few people had experimented with that and said, oh, it's too fragile. Like, we spend all our time manually modifying the HTML in the snapshot. So yeah, I can see why they throw it away in that case, because if I had to change a font and then fix 100 snapshots manually, it's not something that you'd ever consider maintaining.
I guess also because it's not widely used, if you've not got someone to explain it, then you might look at it, and because it's such a different paradigm shift in the way you think about writing tests, that people might dismiss it too soon, I guess.
Yeah, you generally try and find that sweet spot of what's the one test in this project where snapshot testing would deliver the most value with the least amount of friction. And once you have a few of those wins on the board, you generally turn around and suddenly everyone's using it for everything. Like, sometimes I've seen people snapshot test, they're just passing in a string. I'm like, oh, look, it's a very small string. It's probably easy to maintain that inline with an assert. They're like, oh, but the string changes. So we'll just pump it out there and have it snapshot tested. Have you played with parameterized tests yet?
No, I haven't. I saw it was mentioned in the documentation, and I wasn't sure whether that was talking about the normal XUnit parameterized tests, or whether this was another concept which was separate to that.
No, it's support for parameterized tests in the various standard testing libraries. And the reason it needs explicit support is because the file name convention of a snapshot is based on the method name and the test name, which means if you have, say, a parameterized test that runs through 5 iterations, if you don't have explicit support for it, all those snapshots would have the same name in conflict.
I see. So does that automatically get the snapshot parameter and value?
Semi-automatically. I think XUnit, you need to manually pass them through in that Fluent API, but NUnit and MS Test don't need you to pass that through because they have more information in the context.
So could I, in the example we were talking about yesterday then, where I just wanted 2 verifier certs within the same test, could I have used that to actually strongly name it?
Yeah, you could have. So if you pass through an extra parameter into verify, I believe it would just generate a different file name for you. You can also take full control over the file name if you want to and put anything you want in there. But yeah, the case you said where you have multiple verifiers in the same test, it's not something I've seen often. I did add documentation for the approach I showed you though.
In that particular example, because it was an integration test, and I know we both said we didn't like the term integration test, but that's probably another conversation. But it was basically doing some database migration, and I wanted to verify that the target database had the data I wanted. So I didn't want to redo all that for each assert or verify. So I did have multiple verifiers in, but then I think I showed you in our Twitter DM conversation the version where I was using a .NET anonymous object and just creating like a wrapper object and verifying the whole lot. I've gone with that way because then it's just launching one diff tool rather than multiple.
Yeah, I think the reason why I don't often see people doing 2 verifiers in the same test, one of the reasons is that you can actually map a type or a file in verify to produce multiple outputs. So that's what it's doing when you're passing in. So when you're doing the browser testing, you're passing in, say, an iPage object from Puppeteer, and it goes, oh, well, I want to generate one HTML file and one PNG file. So it's kind of like splitting under the covers as an explicit API. So often, if you're inside your own business area and you have your own non-trivially complex objects, you can register your own splitter that splits that into multiple different files as part of one verify.
Right, okay. That might be helpful in this use case then.
So it's the same way, like if you're snapshot testing a PDF, it will split the PDF out into multiple PNGs. So it's the same approach.
Right, I see. In this example where I'm doing the database migration, it's migrating database things, but there's also files that are being migrated. It's basically a repository. The verify is verifying the target files in my tests have been copied across as expected, and also the database is as expected, the target database. So that's kind of another kind of case in this integration test where I've got 2. I don't know whether that would make sense to use a splitter in that case. I'll do a bit more reading on those splitters.
Okay, yeah, I'll chat you the links later.
Cool. So anything else you want to bring up, or shall we do dev tips?
I'd like to do a shout out to Llewellyn Falco. He's the creator of approval tests, which is, I guess you'd say, the predecessor to Verify. And a lot of the stuff I've learned and approaches that I've applied here have been inherited from several years of helping maintain approval tests. So, standing on the back of giants and all.
So that's a good point, which I know it's a difficult question to answer, but as in, should someone be using Verify or should they be using approval tests? Is there an overlap there?
Well, I'm currently a maintainer of approval tests as well, but Verify is getting the majority of my focus. Approval test was written in the age of everything's an attribute. So remember the NUnit of old and even MS Test of old, all the configuration for all those things was through attributes, even the early entity framework, and that's how we configured things. So it was very heavily attribute driven, as opposed to now when you might do Lambda expressions or Fluent APIs and all that kind of stuff. So it was less flexible. It was also written in the time before async. So the whole API and stack is all synchronous, which is problematic when you're splitting and writing multiple files in tests. And it was going to be too much effort to evolve it forward into something that was usable. So I made a hard split. I chatted to Llewellyn about this before I did it, but made a hard split and created something new from scratch. Literally, new project, start with the API that I want to appear and fully wrote the whole thing down the stack. It also, approval test doesn't support the splitting of files that I mentioned. It's always only one file. It doesn't support the JSON serialization. You have to pass in text. So you have to do the serialization of the model on your side before you pass it in. So there's a lot of stuff there that's evolved from my learnings there, but it was just too much effort to incorporate back into approval tests.
And I guess you don't want to break existing users of approval tests by changing too much.
Yeah, and it's one of those difficult things of, we could over maybe 5 or 6 years make a breaking change every few months and get people to upgrade and move forward to something new. People won't be happy with that. Well, okay, let's do a big bang approach and just have one big major change where we break everything. People aren't going to be happy with that. So what do you do?
Well, it's like the whole .NET thing where they just said, right, we're not starting again, but we've got this new thing called .NET Core, which isn't .NET Core anymore, but you know what I mean? And then so there was like .NET Framework, which backwards compatibility, then .NET Core, they're free to change it and break things, make it super fast, which it is incredibly fast now. But just having that break and not starting again, but not worrying about breaking production code that customers are using.
Yeah, agreed.
Cool. So shall we do dev tips?
So I was going to throw out two. One is whenever you're running or debugging an app locally, turn on break on all exceptions. It's initially painful and it generates a fair bit of noise, but especially Visual Studio has really good tooling to now suppress certain types of exceptions. It means if something goes wrong when you're debugging, it's never hidden from you. It breaks in the line where it's actually thrown instead of bubbling up to some global exception handler. It will just improve your life. Turn it on, leave it on as much as possible, and just work around the noise and minify it so that you have a good signal noise ratio. The other one I was going to say is if you're ever designing anything that talks to a network in any given way, whether it's remote service calls, SQL database calls, etc., periodically run your app with a network monitor that captures all that information and shows it to you. It is just too easy to not know that your app is overly chatty or sending way too much data or all kinds of other things that could be going wrong. Even broken links that you just don't know when you're using an app. So yeah, that's my two.
That's really cool. The first one was very similar to one I gave a couple of episodes ago. I think it was in the Visual Studio episode with Kendra Havens. And it does surprise me by how many developers just don't know that you can turn on breaking on handled exceptions. And quite often I'm working with a developer that's trying to help them solve a problem and they're trying to add like logs in there, try and diagnose what's going on. And it's like, just tick this checkbox and it will break on the line that's throwing that exception. So it's really quite powerful. But I must admit, I do, like where you're saying leave it on, I find that way too noisy. So I kind of turn it on when I need it and then turn it off afterwards. Otherwise, it's just breaking all the time.
Oh, you got to tweak down those exceptions. The other thing I often do is leave it running, and for the various libraries I'm using, that's throwing a lot of exceptions. They're using exceptions for flow of control or various other things. And you actually, submit pull requests based on that. Here's a way you can do this without throwing exceptions. Yeah.
Yeah. Well, things like Rider as well, if it breaks on one of those exceptions, one of the buttons says mute and continue. And then that's like adding that as an exception.
Yeah. Exception of an exception.
Yeah. An unhandled or handled exception, whichever way around it is, which always makes me laugh when I see in code an unhandled exception has been thrown, because obviously that's the podcast name, so it just looks weird now.
Yeah, you've overloaded the term in your mind.
I've not tried the second one though, just monitoring network traffic. If I explicitly need to use something like Fiddler, I do, but that's to debug a certain thing. I don't just routinely check what's going on.
It's kind of nice at the phase where you're doing, obviously do performance tests early and all that kind of stuff, but at the time where you are doing performance testing or smoke testing or various other things, or you have a habit of downtime, just turn on, Fiddler, or I think there's about 4 or 5 of them now you can use, and just have a look at how chatty your app is. Open up your app in a browser and look at what it's doing behind the scenes. Can those 100 images it's calling back, can they be mapped together to one image and sliced up? Or, why is this request that is returning an image that never changes not returning a 304? Like, the service should be saying not modified, but instead we're pulling back this large image every single time someone navigates. And you just won't know those things unless you actually run one of those kinds of apps.
Yeah, this is at a lower level than Fiddler, but one thing I've always wanted to learn is Wireshark. But then every time I do, it's kind of, I think, right, this has got a steep learning curve because it's too low level. But to actually learn how to use it properly and actually see what stuff your computer's sending out across the wire, that'd be quite interesting. I can't remember, I think it was .NET Rocks or something, or it might have been the other one that Richard Campbell does. I can't remember the name, the IT-based one, but it was a while ago, an episode on Wireshark, and it sounded quite insane, all the stuff you can actually track using it.
Here's one for you. Crack open Telerik. So I want you to do two things. Find a large solution, like a non-trivial solution, and just open up Visual Studio and see how much, just opening a solution, how chatty that is to the internet, and then do a check for NuGet updates.
I will do that as homework. I think I'd be scared, to be honest. Like just seeing it, I'm kind of like blissfully unaware at the moment of all things going on. Like going back to what we were saying before about dumping out what entity framework actually the sequel that it writes, it's kind of like I'm blissfully unaware.
It's best not to know.
Although I'm going to do it because I really want to, especially the entity framework stuff. I think that's just such a fascinating thing to be able to very easily do, it sounds like, from what you've described.
Yeah, it's well, I think it's easy in the cases I've had. But definitely the much easier one is passing in an in-memory instance of an iQueryable to verify. It's a full unit test. You don't need any services running. It's blindingly fast. Talking to a SQL database is obviously, in that term, integration test. You're definitely in that space when you're recording real SQL statements.
Yeah, a lot of my tests we mentioned before about like integration tests and things, and we were talking about it yesterday. I much favour that over unit tests now, where I would have like Docker running in the background with a SQL database or whatever it is. Like the example I was talking about before, when I'm doing database migrations, in Docker I'm spinning up SQL Server, I'm spinning up Azurite, the Azure Storage Emulator, spinning that up in Docker, and then my tests are actually reading and writing from those real databases, and then I'm using Verify to, I've got a bit of test code which pulls it from that database, and then using Verify to verify that matches. Once you get used to that pattern, because I use that for a lot of my tests now, it doesn't take long at all to do, and it's super powerful. And in the case of things like databases, where if you're using an in-memory database, you might not be capturing things like deadlocks, but this is using a real database, so you capture all those things.
I agreed on that point, yeah. It's very dangerous to rely on tests running against something that isn't the real database instance or a real service instance. I've been in those conversations before where people say, oh, well, unit tests are so much better for all these reasons. But often the primary one is integration tests are too slow. And what you really need to do at that point is have the conversation of, okay, what kind of hardware could we get you so that those integration tests, which are valuable, will also no longer be slow? Because the value of finding a bug in an integration test, find a few of those and you've paid for an awesome dev machine. Like, it's a conversation that you have to have and articulate that to whoever pays the bills.
I think also with the speed of integration tests, again, this whole integration test term is kind of, I'm using it because Microsoft coined that integration tests, ASP.NET integration tests, when actually it's not necessarily an integration test. But anyway, if you go back to the whole test pyramid, where you've got unit tests along the bottom, and because they're really fast, and you've got like front-end tests at the top and integration tests in the middle because they're slower, I'm finding using like the in-memory ASP.NET air quotes integration tests, that's not that slow. So actually that it changes that test pyramid where actually it makes sense to use those much more.
Yeah, so if you want to have that conversation about testing, the one that you want to have is, okay, we're going to have tiers of testing, 1, 2, or 3, 4, whatever. Now we're going to have scenarios about when we run those tests. In each of those tiers, we decide how fast is that test. A test might move up and down each of those categories based on how fast or slow it is. And then, okay, when we're doing local dev, we'll run the fastest ones. When we're doing a release build on local dev, we'll do the fastest ones and the second fastest ones. When we do a package build, we'll run the third tier. All those really slow ones, only run those on CI, or unless you explicitly say on your local machine. And that's the conversation that you want to have. It's not integration tests and unit tests. It's just, How fast or slow are they? How many resources do you need to spin up or tear down to run them? That's the conversation you need to have.
Yeah, I guess that really comes into play when you're doing things like mobile development, where your CI/CD system sends off the test to some third-party service. I've forgotten the names of them now, but which tests on lots of different mobile devices, real devices. I've forgotten the name now. There's a couple of them. And that's obviously going to be really slow. But if you've got different tiers, as you say, where local development, you're not doing that. But before it goes to production, then you can run those.
You also might have one of those slow tests run in the fast tier. It's effectively a smoke test. Like, I don't want to develop for hours and hours and hours with zero confidence that it actually runs on a real device. So yeah, that's how I find that conversation goes better. There's not two categories, and one isn't necessarily better than the other.
Yeah, I think it's also just having that awareness. It's like in the TDD episode with Ian Cooper, I described a scenario at the start where I had kind of in a previous client, because I'm a contractor too, a previous client, they were doing TDD but unit testing pretty much every layer, every class, and then mocking out everything else. And we were kind of spending 99% of our time writing tests. If we refactor something, we'd have to spend a lot of time rewriting all those tests. But the same client was also doing these integration tests we were talking about. And we're finding that a lot of those integration tests kind of rendered all those lots of unit tests, which we wasted lots of time writing, redundant because it was covered at a high level.
There's also phases of development that you've got to consider. So if you're in that initial phase of we're spiking a prototype, have a few, slow tests that test the whole stack. Don't necessarily focus on integration tests, but as you go through the different phases of a project, things change more or less in different areas. Sometimes you need more integration style tests or more unit style tests, and you've got to be willing to evolve those changes through. Sometimes throwing away tests, that just isn't valuable anymore. It changes along that spectrum of time as well. It's not just you can't apply those rules consistently all the way through.
Yeah, yes. It feels scary, like throwing away tests when you spent time writing them. But as you say, it's kind of, if you don't need it, you don't need it. Cool. So we are probably running out of time. And I'm kind of aware that it's probably very late for you over there, isn't it? Man, I go to bed like 9:30, so everything's late for me.
No, it's one doing fine here. I will crash. The problem with doing one of these things late is your mind's buzzing now. So I'll probably have half an hour of TV before I crash.
Fair enough. So what's the best way for listeners to reach out to you if they've got any questions?
So I'm on Twitter. Feel free to reach out to me on Twitter. My DMs are open. Obviously, the GitHub project will have links in the show notes to Verify. Discussions are open on Verify as well. So if you just want to have a conversation there about various different things. And if you want to ask me about any of my other projects, yeah, feel free to reach out. Lots of opinions on lots of projects and lots of things. Feel free to ping me if you have questions.
Well, I'm definitely going to start using this moving forward. And like you mentioned, you're a contractor, I am too. So I'm going to be introducing this to any team I work with because, yeah, it just sounds such an incredible time-saving thing and just so powerful.
Oh, and I made the offer to you, but it's pretty much an open offer. If someone wants to get into snapshot testing, if they want to do a quick call to work out what the best way to do it or a walkthrough, especially if it's an open source project, I love to help open source projects do this kind of stuff. Let me know and we can jump on a call. And if you want to do it in a more formal capacity with a business, I can do that as well as, some kind of temporary paid thing. So, yeah.
That's amazing. So seriously, thank you so much for joining us. It's been really great chatting with you. And thank you for your tool as well, for Verify.
Thank you very much for having me.
That's all right. And a big thank you to everyone for listening. A quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please help me spread the word on social media. I normally use the hashtag unhandledexception, and I can be found on Twitter at Dracan, Dracan, and my DMs are wide open. And my blog, danclark.com, has links to all my social stuff too. And we will include links to all the things we've mentioned today in the show notes, which can be found on unhandledexceptionpodcast.com.